Hello everyone, once again welcome to my channel. So today I am going to discuss about the one of the most important, it will comes under in a neighborhood reaction as well. So that is in Mistonube reactions. Yes, Mistonube reactions. This is the most important in your competitive exams like CSR, GATE, any MSc competitive exams. So this question is quite important. If you see this, how we are going to remember this Mistonube reactions? I said many times. If you remember any neighborhood reaction, just three things you should know. First, what is the substrate they are using, which reagent they are using, and which product is they are using. Simply these three things we should know that, so we are able to understand this neighborhood reactions. We are not going to by heart any neighborhood reactions. So substrate యూజ్ చేస్తున్నాం, reagent యూజ్ చేస్తున్నాము, product ఏమిస్తుంది. These three things we should know, right? So here Mistonube reactions, here comes the Mistonube reactions. This is the most important. When you see this dead plus ppH3, blindly you say that this is the Mistonube reactions. When you that in any neighborhood reaction, any questions, you say dead plus ppH3, simply you should say that this is belongs to the Mistonube reactions, right? So here you will, it will give 100% of inversion product. We will get in this reaction 100% of inversion product. If you see what is that 100% of inversion products, if they are going to give the substrate in above the planes, so we will get the product in below the plane, that is in inversion. So if you see the reaction mechanism, so that we can understand what is that exactly happening in this reaction, so you can see the mechanism. What is that? Mainly I will tell that, what is the inversion product. Inversion in the sense, we will take one example here. So it is in above the plane, so obviously it is going to form below the plane. This is for what? Inversion product. Okay, we will see the example so that you can understand that mechanism. First we will see the mechanism. After that, solve the some questions too. So here you can see mechanism. Dead plus ppH3, right? C double bond O, N double bond N double bond C double bond O E T. Diethyl azodicarboxylate, the dead plus ppH3. So paspin, tripaspin, right? So in this tripaspin is going to attack on this nitrogen. See careful. This bond is migrated towards the nitrogen. So you will get ETO, C double bond O, N minus N ppH3 positive charge. Then you will get C double bond OET. After workup NuH, so after workup it will take the protons from there. So you will get ETO, C double bond O, NH, N, ppH3, positive charge, C double bond O, ET, right? So it is treated with a alcohol. So this alcohol, if you see this alcohol is going to, this lone pair of electrons is going to attack on this ppH3. This bond is migrated towards the here. So you will get ROH ppH3, right? So after that you will get here nitrogen minus. So after workup you will get NH. So here this is the positive, right? See here, hydrogen will leave here because of instability. So you will get ROPPH3. It is in positive, right? See here, when this nucleophile is attack on nucleophile, it is going to attack an SN2 pathway, and this oxygen is going to leave. So you will get NUR. This is for what? Your product. Okay, this is for what? Your product, and ppH3 you will get byproduct. So this is, it is going to attack on the inversion compound will get. If you see the example, so that you can understand, this is for what reaction mechanism, actually Mistonube reaction. And if you see the if you see the example, so that we can understand, right? I will give the examples to you. If you see, first here above the plane OH, stereochemistry is the most important in these reactions. Please note down this. And one is PPH3 plus dead, and second one is CH3 COOK, first, second, third, H2O. Okay, and next question, here you have a OH above the plane. It is treated with first PPH3 dead, second one is CH3 COO minus K plus, third one is KOH H plus. Okay, if you see these reactions, first, it's very simple reactions. If you say dead plus PPH3, if you say the dead plus PPH3, obviously you should say for this is the Mistonube reactions, right? So in this Mistonube reactions, you will get first, it is treated with CH3COO. So you will get, I'll write directly, I'm not going for a complete mechanism again. So it is going to give CH3COOH. So it is in above the plane, right? So you will get the product in below the plane. Okay, below the plane. So again it is going to treated with H2O. H2O is nothing but OH minus H plus, right? This OH minus it attack on this carbonyl center, and this bond is migrated here, this bond is migrated here. So this bond is migrated towards the oxygen. You will get here O minus. After workup, H plus. So it is going to attack on this bond. So you will get OH. This is for what your product. If you see coming to this reaction has also, so it is in uh, above the plane, right? So you will get CH3 C double bond O CH3. After that it is treated with OH minus H plus. So this OH minus it attack on this place, and this bond is migrated here, and this bond is migrated here, and this bond is migrated towards the oxygen. Finally you will get the compound is OH. This is for what your product. I hope you understand, right? So if you see the one more examples to you. Oh my god, it is not moving. If you see, I will give one more examples to you. This is quite important. OH. So here CH3, here H, D, above the plane it is in H. Okay, NaOH. As well as same reaction, OH, Br, above the plane H, and below the plane D, CH3, H. So this is for what? If this question, if they are, let us assume if they are going to give these questions to you, so when it is in you find this type of questions, so it should be it is in base, right? Base, what is going to do base obviously it will take the protons from here, right? So you will get negative charge. So in this negative charge and this leaving group, it should be in anti-perpendicular. Okay, I hope you understand. This negative group and this leaving group, it should be in anti-perpendicular. This is for what? Anti-perpendicular. So when it is in anti-perpendicular, so this bond is migrated towards this carbon, this bromine will leave, so you will get here, you can see CH3, it is in above the plane hydrogen. So as it is, you can write here, you have a H, it is for D. And coming to this reaction, it is in not perpendicular, anti-perpendicular, right? It is in same side, it is in not anti-perpendicular. So what you are going to do, you can rotate for this is this groups. You can see here, when you are going to rotate OH, CH3, H, if I am going to rotate this compound, so it is in above the plane is going to convert it into below the plane is going to convert it into above the plane. So if you are remove this, so you can see here in the base, right? Base what will do here, proton will take, you will get negative charge. So this negative charge is going to attack on this bond, so this bond is going to leave. So final compound you will get, I will write here, not like this. So O, so what are the below the plane CH3, above the plane hydrogen, so here above the plane D, below the plane hydrogen. This is for what? Your product. I hope you understand these reactions, right? Mistonube reactions, it's very simple. When you see this plus PPH3, simply you say that this is belongs to the Mistonube reaction. And you 100% inversion production, it is follows the SN2 pathway, SN2 reaction. So SN2 in the sense will get 100% inversion product. What is that inversion? If they are going to give the above the plane side, so we will give the answers to below the side. This this small change you can write in this reactions. I hope you understand the reaction. Thanks for watching this video to everyone. Thank you so much.